Various manufacturing process in sheet metal. In this video, we are going to see about the various manufacturing processes in the sheet metal. Various manufacturing process in sheet metal. Sheet metal processes includes cutting and forming operations performed on thin sheet of metal. Cutting is used to separate large sheets or coils into smaller sheets, to cut out a part perimeter, to make holes in a part. Forming includes bending and drawing, which are used to form sheet metal parts into required shapes. The wall thickness of the sheet metal almost remains constant when it is deformed. Only it differs slightly from the thickness of the initial sheet metal. The sheet or plate used in sheet metal process is produced by rolling. Most sheet metal processing is carried out at a room temperature, that is cold working. In some cases, if the metal is thick, brittle, requires significant deformation, then warm working is carried out rather than hot working. Sheet metal products are called stampings. Sheet metal commercial applications includes automobile and truck bodies, airplanes, railway cars and locomotives, farm and construction equipments, small and large appliances, office furnitures, equipments and computers, etc. Shearing process. Example of the shearing process is punching machine, punch, stripper plate, guide post. Sheet metal cutting is accomplished by a shearing act between two sharp cutting edges. Sheet metal. The upper cutting edge is the heat and the fixed lower cutting edge is the die, and sheet is placed in between. Plastic deformation occurs in the surfaces when the punch moves and begins to push the sheet. Once the punch travels downwards, penetration occurs. If the clearance between the heat and the die is correct, the two fracture lines meet, resulting in clean separation of the work. Bending process. Bending is the operation of deforming a sheet around a straight axis. The neutral plane lies on this straight axis. Example of bending process is press brake machine. Some of the parts are ram, punch, plate, sheet metal, bed, die. During bending, material are stressed beyond the elastic limit in tension on the outside and in compression on the inside of the bend. There is only one line, the natural line, that retains its original length. Bending is sometimes called as forming, which involves angle bending, roll forming, etc. Drawing process. Process of forming a flat piece that is blank into a cup shape. Some of the parts are blank, die, base, punch, blank holder. The punch pushes the blank into the cavity, thus forming a cup shape. If the depth of the formed cup is half of its diameter, the process is shallow drawing. It is termed as deep drawing if the formed cup exceeds the diameter. Some of the applications are beverage cans, sinks, automobile body panels, etc. Various manufacturing processes in plastics. In this video, we are going to see about the various manufacturing processes in plastics. The manufacture of a popular plastic product requires satisfying the various mechanical and physical property requirements through the use of the most economical resin or compound that will perform satisfactorily and coupling it with a manufacturing process that is compatible with both the part design and the selected material. Casting. Casting is the simplest of the shape forming methods because no fillers are used and no pressure is required. While not all plastics can be cast, there are a number of castable thermoplastics including acrylics, nylons and urethanes. Some thermosets, that is such as phenolics, polyesters, epoxies, silicones and urethanes can also be cast, as well as any resin that will polymerize at low temperatures and atmospheric pressure. Because of the need for curing, the casting of thermoset resins usually involves additional processing, often some form of heating while in the mold. Injection molding. Injection molding is one of the most common processing methods for thermosetting plastics. Some of the parts are mold, tie bar, nozzle, platen, heater, mold cavity, screw, hopper, resin charge. It includes 3 steps: melting of the polymer, injection of polymer into a closed mold, ejection. The above steps can be achieved by 2 types of injection molding machines: screw machine, plunger machine. Extrusion. Extrusion is the base of all shaping process. It is widely used for thermoplastic and elastomers. Some parts of the extrusion machine: hopper, hydraulic drive, heating chamber, screw. Die. This process is similar to injection molding. The work happens in 3 phases: feed section, compression section, metering section. Feed section. Plastic granules are loaded in the hopper at one end. These plastic granules move forward due to the action of rotating screw. The screw runs by an external motor which is connected through shaft. Compression section. The barrel contains heater bands which melts the feeded plastic. Rise in volume increases the compression of the material. Metering section. The material is forced to flow through a die orifice to provide long, continuous product. Product shape is determined by the shape of the die orifice. Before that, the material passes the breaker plate and expels out through the die. Then, the plastic is called extrudate, which then cooled and machined. Blow molding. A thermoplastic resin is heated to a molten state. It is then extruded through a die head to form a hollow tube called a partisan. The partisan is dropped between two mold halves, which close around it. The partisan is inflated by pressurized air. The plastic solidifies as it is cooled inside the mold. The mold opens and the finished component is removed. It is classified into three types depending upon the production of plastic bottles, jugs, and jars. Calendaring. An important method of making film and sheet is known as calendaring. In this process, the plastic compound is passed between a series of heated rollers. It comes out from the rolls squeezed into film or sheet. Thickness is controlled by a combination of squeezing and altering the speed of the finishing rolls. The finished product is cooled by passing through water-cooled rolls. Vinyl floor tile, cellulose acetate sheeting, and films are some of the applications. Thermoforming. In this process, the sheets are clamped onto a frame and then heated to soften but not melt the plastic. A mold is then brought into contact with the sheet and deformed into the desired shape. The process is widely used in packaging of consumer products and to fabricate large items such as bathtubs, contoured skylights, and internal door liners for refrigerators. The methods by which the forming step is accomplished can be classified into three basic categories: vacuum thermoforming, pressure thermoforming, mechanical thermoforming. Compression molding. The molding process can be carried out with either thermosets or thermoplastics. Some of the parts are upper mold, bottom mold, control unit, actuator. Working of compression molding machine. In this process, a pre-measured quantity of plastic in the form of charge or briquettes is placed into bottom half of a heated mold. Hydraulic presses are usually employed to provide the pressure for compressing the plastic compound. The upper half mold is moved to increase the pressure. Charge flows towards mold shape, which also forces out the air. Higher mold pressure leads to defects like cavity, and lower mold pressure causes porosity. The object of compression molding is to bring the plastic to virtually molten state. Transfer molding. Transfer molding is a modification of compression molding. Some of the parts are control unit, actuator, punch charge, mold cavity. Thermosetting charge is loaded into a transfer pot where it is heated. This charge is allowed to flow into an orifice, that is, spruce mold, by applying pressure where curing takes place. This action is done by a punch as the mold closes. The material to be molded is often preheated by radiofrequency methods, and where it is desired to improve toughness and strength, reinforcing fillers may be used. Product finishing methods. In this video, we are going to see about product finishing methods like painting. Electroplating. It is a coating technique. It is the most important and most frequently applied industrial method of producing metallic coating. Example: spoon. It is a process by which the coating metal is placed on the base metal by transient, a direct current through an electrolytic solution containing the soluble salt of the coating metal. The article to be plated is first treated with organic solvent like carbon tetrachloride, acetone, tetrachloroethylene to remove oils, greases, etc. The cleaned article is then made as the cathode of the electrolytic cell. The anode is either the coating metal itself or an inert material of good electrical conductivity. The electrolyte is a solution of soluble salt of the coating metal. When direct current is passed, coating metal ions migrate to the cathode and get deposited there. Thus, a thin layer of coating metal is obtained on the article made as the cathode. In order to get strong, adherent and smooth deposit, certain types of additives, that is glue, gelatin, boric acid, are added to the electrolytic bath. In order to improve the brightness of the deposit, brightening agents are added in the electrolytic bath. Electroplating is performed to improve the appearance of the workpiece, to improve its corrosion, abrasion, or wear resistance, to improve electrical conductivity, to change a dimension, or for a combination of reasons. Anodization. It is a process by which a thick oxide coating can be produced on the base metal alloys by making it as anode in the electrolytic cell. It is carried out by passing a moderate direct electric current through a bath in which the metal or alloys is suspended from anode. The electrolytes used to assist this process are usually sulfuric acid, chromic acid, phosphoric acid, boric acid, and oxalic acid. Anodizing on aluminum. Base metal, that is anode, aluminum. Cathode, inert metal. Electrolyte, 3% chromic acid. Temperature, 40 degrees Celsius. Current density, 0.2 to 2 mA centimeter to the power of -2. On electrolysis, the oxide coating forms at aluminum surface as a result of progressive oxidation. The outer part of the oxide film formed may be porous. This can be sealed by immersing in boiling water. This treatment decreases the porosity and increases corrosion resistance of the film. Spray painting. Spray painting is probably the most widely used paint application process because of its versatility and the economy in the use of paint. In the conventional technique, the paint is atomized and transported by the flow of compressed air. In a variation known as airless spraying, mechanical pressure forces the paint through an orifice at pressures between 500 and 4500 psi. This provides sufficient velocity to produce atomization and also propel the particles to the workpiece. One means of applying thicker layers in a single application is known as hot spraying. Special solvents are used that reduce the viscosity of the material when heated. Upon atomization, the faster evaporating solvents are removed, and the drop in temperature produces a more viscous, run-resistant material that can be deposited in thicker layers. Industrial robots can be used to move the spray heads in a manner that mimics the movements of a human painter, maintaining uniform separation distance and minimizing waste. In addition, use of a robot removes the human from an unpleasant and possibly unhealthy environment. Powder coating. Powder coating is yet another variation of electrostatic spraying, but here the particles are solid rather than liquid. Several coats such as primer and finish can be applied and then followed by a single baking, in contrast to the baking after each coat that is required in the conventional spray processes. In addition, the overspray powder can often be collected and reused. While volatilized solvents are no longer a concern, operators must now address the possibility of powder explosion as well as the health hazards of airborne particles. Modern powder technology can produce a high-quality finish with superior surface properties and usually at a lower cost than liquid painting. Powder painting is more efficient in the use of materials, that is, the overspray can be captured and reused, and lower energy requirements. The economic advantages must be weighed against the limitations of powder coating. Dry systems have a longer color change time than wet systems. The process is not good for large objects, that is, massive tanks or heat-sensitive objects. It is not easy to produce film thickness less than 1 milli, that is 0.03 millimeter.